There is a useful modeling concept that is available in many 3D apps, including Houdini, where you see the original geometry projected onto the subdivision limit surface. That allows you to see the flow of the geometry without cluttering the view with the newly added geometric detail. And that is exactly what we'll create in this lesson. Bring any geometry that you like to use, and make sure it has point normals. Loop over each connected piece of geometry. We are not doing this just for speed, but the accuracy of the minimum projection can greatly improve when we deal with each connected piece individually. Inside the loop, create a convert line node. And resample it to ensure the polylines have enough detail to capture the curvature of the subdivision limit surface. Remember, if you only project the original geometry onto the subdivision limit surface, you will only get a slightly shrinked version of the input geometry. So essentially, we have to subdivide the polylines before. Copy and paste the latest limit surface sample subnet from the previous lesson, and make sure to connect the polylines into the first input, and the current loop piece into the second input. Now, we have to merge the subdivided version of the input geometry with the projected polylines. As you can see, some parts are more faded than others. It is because the polylines lie on the subdivision limit surface, whereas the original geometry is only subdivided twice. So some parts of the polylines are bound to be inside more than others. We can easily fix this by weight tracing the polylines against the subdivided geometry. So first isolate the subdivided piece of geometry that corresponds to the current loop piece. Now create an attribute wrangle. What we will do is to fire a ray from each point along the point normal against the subdivided piece of geometry. If we have a hit, then we sample the normal at the hit location. Compare this to the current point normal. If the dot product between them is greater than 0, that means they are both facing the same direction, short of being perpendicular to each other. If that is the case, we move this point to the hit location. Essentially, this will push the points that are inside the subdivided geometry outside. And as you can see, the fading is gone. But we can still improve this. We can displace the polylines outward just a little bit more to make them more pronounced. So create another attribute wrangle after the for loop. We will just implement a basic peak operation. You can see, even with a very low peak value, the polylines became much more pronounced. This depends on the scale and the topology of the incoming geometry, so you might have to use different values than mine. Such a simple but neat effect. Essentially, you can reference an object that you are interactively modeling inside another object and create polylines from the actively edited object to have your own isoline display. It will be fast enough to use it interactively. And with that said, see you guys in the next lesson.